Here we go. Oh, I didn't do that right. Um, so our last study set for this term. So amides or amides, and so we're going to name them. This first one is an amine. So be careful of that on the third celebration. Something stuck in my throat. Um, and recognizing the amide. So this carbon with the double bonded oxygen has to be attached to the NH2. So A and C are amines, and B and D are going to be the amides. So for naming the amines, this first one, this side group on the left-hand side, we can't name it easily. So we're going to have to go with the IUPAC, which is our longest chain is 5, and we'll make the nitrogen attached there. So 1 pentanamine. And then we have a methyl at 2 and on the nitrogen. So again, you can say 2N or N2. I still have never looked it up because I don't really care that much. But if you care, you can let me know. And I'll forget again next year. All right, on the amides, that is always number 1 where the double bonded oxygen is. So 1, 2, 3, 4, 5. So it's a pentane. And there is a 1 here. So for the amines, if you go with the IUPAC, you have to put the number in the name. For the amides, you do not, because that's what being an amide is. And then we do want to say that there's a methyl at number 3. So 3-methyl pentanamide. So just be careful when you do the the third celebration on Monday. This one, we have, so we want to do our longest chain. So 1, 2, 3, 4, 5. And we would just say we have a 1,4 pentane, and then diamine. You want to put the di in front of the amine because there's 2 amines, not 2 pentanes. You could have also, so that would be the IUPAC way. You could have also just named it as a pentane, and then said the NH2s are side groups. And so then they would be a 1,4 diamino. So when it's a side group, we end it with O, like amino acids, because then they're a side group. If it's the main part, you end it as the amine with the E. So either name, the first name is probably the IUPAC name, and then our amide is, here's our number 1. They must all be pentanes. 3, 4, 5. You guys have all been great about numbering. So pentanamide. And this is an ethyl, this is a bromo. So carbons get numbers. So 4 bromo, N ethyl, N methyl. So there's our methyl. So 4 bromo, N ethyl, N methyl, pentanamide. They are not bases like amines are, and that has to do with the carbon double bonded oxygen is pulling the electrons. So the oxygen is so greedy for the electrons. Those electrons are not behaving the same way, so there's no attraction for the hydrogen. So a base is something that attracts the proton, the hydrogen ion, and that double bonded oxygen is pulling these 2 extra electrons that would be there towards it. And so you don't have the effect you have for an amine. And it also takes away the smell, which is nice. All right. The carboxylic acid these came from, and the amine. So just cut it. These are actually similar like the esters. So this whole celebration, everything's very similar. And this side would be our carboxylic acid. You can draw the carbons like they are on here, and we would add, this would be our OH that we would be adding. So acetamide, I'm sorry, acetic acid. It was acetamide. And then the other side would be the amine group. So there would be a hydrogen added. So basically you're adding a water molecule, an OH and an H, and everything else is the same. So the CH3, and this would be an isopropyl. So this one you would name as a common name. So just something, because some of you on your worksheet were loving putting the ends with everything. If you use the YL ending and alphabetize, then you're using the common names. So you're just saying isopropyl methylamine. You don't put the capital N. All right, on this one, the pentane part is going to be our carboxylic acids, 2, 3, 4, 5. And so there's our acid. We can actually go ahead and draw it. Always a good idea. And then our amine part is to make the amide. There would be a hydrogen there, so we're cutting there. So pentanoic acid. I'm also writing the names. It did not ask you to do that here. But again, some students, that helps them. When they see the words, it helps them, because sometimes when we make sketches, especially looking on the computer, I don't know how we've all made it through this term, but the words, then when you go back, redo your study sets. So again, that would be the last 4 study sets. So study sets 9, 10, 11, and 12 would be the 4 that are on the celebration, and your worksheets. And I will have an office hour Monday at 5 p.m. And you can always send me an email. And yeah, if you're somebody who has to take the test early because of different reasons, just send me an email and we'll do it at 4 o'clock. Or if some other reason you can't do it Monday, just talk to me. Yeah. And we get methylamine. Now, none of these say that we're in an acidic or basic situation, so we just split it into the 2 parts. All right, on this one, again, we're going to get a methylamine. And I like to show the hydrogens on the other side from the NH, from that group. And this would be our carboxylic acid. And we would just add the OH. So this would be 1, 2, 3. So a 2-methyl propanoic acid. Yeah. All right.
Could it also be an isobutyric acid?
Yes. Isobutanoic or isobutyric. Yeah. Yes, that is an isobutyl. All right. And then this one, butane. Put our nitrogen, and then we're going to have a methyl on the nitrogen and a 2,3. And just a reminder, on nitrogens, you have to always write the letter H in, and same with oxygens. So it's just the carbon. So that straight line means a methyl. And then we just cut it in half. And there's our acid, which would be 2,3-dimethyl. So all the number stuff is going to stay with it. And then the butane will become butanoic or butyric acid. And then the methyl will just be another, same thing, methylamine. So however you can show it with the line. Again, you draw the hydrogens in and show the line. The line can be above, left, right, just different direction from the hydrogens. Any questions from this first page? Doesn't all fit on my game shot. All right, halfway done. So this one for hydrolysis, so we're cutting in half. So really for this celebration, you're either going to be cutting into 2 pieces or putting them together. And you get 2 hours again, but most of you have been taking less time than that. So we're cutting between the carbonyl and the NH3. The difference, these are the exact same molecule. The only difference, so we're going to have 4. Whoops. So butanoic acid and the methylamine are our two products. So you can show zigzags or you can write the carbons in. On the first one, if it's just cutting it, just keep it simple. On this one though, with the HCl, they both end up as acids. So the acid is already an acid. What's going to happen is on this one, we're going to pick up the nitrogen is going to pick up an extra hydrogen. And we would show the plus on the nitrogen. And then the chlorine, the best way to show it again would be to show brackets and to put the chloride on the outside. So it's not a chloro. The chlorine is not attached to the nitrogen. It's a cation anion attraction. So we make an ion. All right, and then we do the exact same thing again for C, but this time we're going to do it in the presence of a base. And so they're both going to come out as bases. So this hydrogen is going to pop off and we're going to get an O negative and the sodium with a plus. And the nitrogen stays as it was up above. So those three really went together. They were the exact same molecule, cutting it. So my recommendation is if you see the acid or base, just cut them and do the water part, and then you can go back, or at least just cut it and do the hydrolysis and say, okay, I got the hydrolysis, and then you can do the fancy ionic part. All right, and then this last one, we're just cutting it. It does help to put the slash. I do notice that people who put the slash tend to get it, and we can go back and name them just for more practice. So we're going to get the acid there with the OH. And then this one, you do show the nitrogen. We have the methyl. And yeah. So they all had two products. So this is, on this last one, this is N-methyl aniline. So aniline is when the nitrogen is directly attached to the benzene. And then this is, of course, benzoic acid. The original name would have been N-methyl N-phenyl, because this just gives us more opportunity at practicing naming. Sorry, my handwriting's not. And then benzamide. So we started with the amide. So in this case, that phenyl is considered a side group. So N-methyl N-phenyl benzamide. And amides, we always put the N's with them. Any questions, reactions? All right, and then more practice with this boiling point. So again, the celebration will be like the other one. So probably be, I haven't thought about it. So the higher boiling point, it's the amide. Why? They're the same size. They each have a methyl on a butane, and an amide and an ester both have a double bonded oxygen. The amide is going to H bond. If we go back up here, see how we have the hydrogen on the nitrogen? So the amides, not all of them are going to hydrogen bond, but this amide is this guy up here. And it has that hydrogen on the nitrogen, so it H bonds. The methyl butanoate does not. So make a picture, draw a picture and look for the H bond, so that hydrogen on the nitrogen. On the next one, as soon as you see ammonium, it's going to be our winner because it's ionic. So the ones that have the sodium or the chloride, they're going to be the ionic, and that is going to, no matter what the other one is, it's going to win. On the next one, it is our second one. So the butyric acid has an H bond, but the amino group has an H bond and the butyric acid has an H bond. So we have a double H bond. And so more H bonds is going to win. All right. The next one, they both H bond. They're both amides. So then we look at the size. So this is just 2 carbons, and this is 9 carbons. So higher surface area or more carbons. And that is because they're the same group, same family. So you first want to look for that difference. What was our thing? Ionic is our top, then H bond. Then we have our polar. Esters are polar. So this guy is polar, but it doesn't H bond. And then the non-polar. And then if they both are in the same group, then we look at this number of carbons. All right, and then our last one here, this one's easy. So this guy is non-polar, pentane. That's where we started 2 months ago, 10 weeks ago, I guess. So it's just an ane, ene, and ine. They're special. They are our fossil fuels because that's what you all break down to. We're carbon based. This is going to H bond. The amine has the NH versus non-polar. Questions with that. So again, this is the highest attraction, and non-polar is the weakest. So water soluble, it's always going to be asking about water solubility because we are water based, over 70, around 70%. So it's the most important element. And so it's not a good question. Can we skip to B? But there's really not that much of a difference in these. So the butyl amide with the carbon group, and then this one is going to be the 4 carbons, and then the oxygen with the methyl. So they're really the same size. This having the H bond isn't going to make that big of a difference. And so if I was going to ask you these, one of them would be a different size. And so they're both going to be partially water soluble. They're right on the cusp of where we would say not. So let's just throw this question out. Not a good question. I don't think it's a good question. If something like that showed up, that's why it'll be on Zoom. You could come in and I probably would have noticed it and I would just discount it anyway. B is because we see ionic. Ionic is going to be very water soluble. This is also not a good question. Why is this one not a good question? This is only a 2 carbon amine. This is water soluble too. So they're actually both very hydrophilic. There is like ranks of hydrophilic, like they completely dissolve. They dissolve partially. So the ones above would be like partially hydrophilic. What was that? The amphiphilic question. This one, because this is only 2 carbons, it's going to be very hydrophilic. So again, these are not great questions. I think I go through this every year. My last question on my last homework set, and I'm like, really? But I didn't change it. Now, when you get to 4 carbons, this one's probably water soluble. This one's our better answer because that extra amino group. So you have more polar. It's much more polar. More polar, it has the H bond because we have the double oxygen of the butyric acid, which is going to be hydrophilic. Yeah, I can't believe I wrote this question. I think what I did is I just copied from there and just went with it. But this is a good reminder. This is the alpha position. This is the beta position. So the position number 2 is alpha number 3. So gamma means the nitrogen is here. This is actually GABA, which many of you have taken anatomy. So GABA is the neurotransmitter that helps our brain stay calm. And glutamic acid as glutamate as an MSG, but glutamate and GABA balance each other out. but this extra nitrogen and H and these, but they would both be hydrophilic. So again, I don't like that question. So there should be a difference in size, or one is very hydrophilic and because of size, or it has a lot more. Right, the next one's a good one. This had 9 carbons, and this had 2 carbons. So the 2 carbon is water soluble. 9 carbons, both the 9 carbon and the pentane, the nonpolar, are hydrophobic. A review of our terms. So they don't like, of all these in this question, just the nonamide and the pentane, they're the only ones that would not mix with the water. And so the butylamine, it's polar. So it H bonds, and so it loves water. And again, A, B, and C weren't great questions. Usually the ionic one, we don't worry about the number of carbons. I just compared it to something that was too small. So I am more mindful usually on the celebration. All right, any questions? Again, your celebration is Monday at 6 o'clock. I'll be here at 5 o'clock to answer questions. Or last term, a bunch of people just came at 5 o'clock to hang out and chat. And I'm going to stop. And thank you. Thank you again for a great term.